All right, we should be live now, I believe. Let me know if you guys can hear me. Welcome to World Quan Office Hours Week 3. I noticed that when I put on the, when I modified Jupyter Hub with the video links, I for some reason didn't update the office hours counts. In other words, if I go here, I go to Control Panel, and I go to Video Links. Forgot to change it to say 13, 14, 15, 16, since we are in week 4 already. It's a little hard to believe, but we're already at week 4. All right, and can you guys hear me? All right, yes. Thank you, Amadara, to let me know that you guys can hear me. Hello, Joseph. Welcome, Joseph. Welcome, guys, to World Quan Office Hours. I got a couple of things on my agenda. On the very top there is inheritance. We talked about it. Hello, Alfred. We talked about inheritance, but we haven't done too much with it. So let's go ahead and talk about today, flesh out the example of inheritance. I'll show you kind of a toy example. And then what I also want to do here is also show you some examples of using inheritance in real life. Because I said before, oftentimes in object-oriented programming, you'll be rarely making your custom classes from scratch. Instead, you'll be inheriting from some other pre-created class. Someone's saying AWW question mark. I believe that is the name of this application I use for this whiteboard. I'm not sure what it stands for exactly. I don't know. I don't know what it stands for. All right, so do let me know if there's any additional topics you want me to throw up on the agenda for us to consider for today's office hours. In the meantime, I'm going to go ahead and get ready and open up that notebook we were working on last time that had our discussion of inheritance. Let's see, did I not rename that? I may not have renamed that notebook. There it is. Go ahead and rename it. I'll just rename it for today's date. Okay, kernel, and restart and clear output. Okay, let's go and pick it up with inheritance. All right, so what we did before here is we created a custom class called pet. It's got 2 attributes for a pet. It's got the name and the age, and it also has a method called speak. You give it a message and it returns that message. And here we create an object of this pet class, apparently a pet called Pumpkin, of age 5, and we let it speak, saying, hello, I can talk. Hello, Lyndon. And then we can, let's say we want to create a dog. So we can think of a dog as a type of pet, a variety of pet. Someone's saying there's no sound on their end, so can you guys hear me? Can you guys hear me? Just want to make sure that it's not it's not a widespread issue. All right, thank you, Alfred. All right, thank you guys for that confirmation. So here we define a dog class. It's got 3 methods, right? It's got the name, age, whether it's upright or sitting down. It's got a method speak, a method called bark, and a method called sit. So if we were to look at this, while this works, in other words, I can create this class here, and I can create an object of this class, and I'll give this dog a name called Woofy, and I'll make this dog, let's say 10. My dog. I call my dog, I could say things like speak. Hello, I am a dog. Someone is saying there are other people waiting in the link. They should be able to, if they hit refresh, it should work out. This is the same link that we have. If you go here and I right click, this is a link we provide, then it should open up this stream here. I think the issue is that they might need to hit the refresh button. So if you do have that other stream open, do let them know they have to hit the refresh button. But if you look at it, it's the exact same link that we provide here. So unfortunately, they do have to refresh. I think it's some sort of quirk in YouTube, unfortunately, that in order for them to, you might get to the page beforehand, but you have to reload. It's a little annoying. In fact, maybe what I should do from now on is make sure I type in a message in the stream saying, don't forget guys to reload, to refresh the page so that the stream connects. But thank you, Naya, for pointing that out. All right, so I see some people coming in a little late because of that quirk, but thank you guys for letting me know that. I will make sure part of my workflow and when we do these office hours that I go ahead and type, hey guys, don't forget to refresh. Like I said, it's some quirk in YouTube where you have to, even though you're on the correct page, you have to hit refresh, reload for the stream to connect. All right, Kinji has a question about reduce. Go ahead and let us know. I'll go ahead and put it on the board and prioritize it, so do let me know your question on reduce. Now with that said, let's go back here with our description of this dog class. Someone's saying is what they've missed. You haven't missed too much. Basically what I've done so far is I've defined a pet class, create a pet object, define a dog class, and started to use this dog class. However, as we see here, there is repetition in what the dog class does compared to what the pet class does. Notice there is some repetition, some replicated functionality. So while this can work, and it could work out for our task, a better approach is to exploit what is called inheritance. Assignment is on the agenda. Don't worry, I don't have it here, but I'll put it. Assignment is on the agenda. So what we need to do is we need to create a dog class that inherits from this pet class. So in other words, what we want to do, if I were to sketch this out, we have a pet class right here. And we're going to create a dog class that basically is going to build on top of this pet class. And that's all done through this concept of inheritance. Yeah, exactly. We have to inherit from the pet class. So let's try that out. Let's see that syntax. So I say class dog, but instead of putting object right there, I'm going to replace this with the name of the class that I'm inheriting. So I'm going to inherit from pet. And there we go. We've created a dog class that inherits from the dog class. Now you might be wondering, so what does it mean for us to inherit from this class called pet. Well, just like inheritance in real life, what this means is that this dog class has all the same attributes and methods of its parent class. Inherited all the attributes, all the methods of that base class, or the class it inherited from. So now what we need to do is we need to flesh out the differences, the things that make it different compared to the pet class. And one of those differences is that the dog, all objects of the dog class have 3 attributes. They have name, age, and upright. All objects of the pet class have name and age. So notice the overlap. A dog object has an additional attribute called upright. So what we need to do is we're going to define the init method. And the reason why we need to define the init method is because the dog's init method needs to be slightly different compared to the pet init method. Similarities, but there's a difference. So we're going to go ahead and do here is we're going to say self, and we say, okay, well, the dog accepts a name, an age, and that is it. However, we're going to make use of its parent's init method. This here creates those first 2 attributes, name and age, and then we define the additional attribute called upright. So in other words, we are invoking the init method of the parent. And then we add the additional functionality that is missing in creating the upright attribute. Do let me know if there are questions. Let me look at the chat here. Someone is saying, I need to understand how to use bash commands on the notebooks. Couldn't do it on the local system. Perhaps it's a special feature added to this course. So RDX, those commands probably don't work on your local system, your personal computer, because you might be wondering, you might be running Windows. Those bash commands are for Unix-like operating systems. Think of Linux and Mac OS. So if those commands aren't working for you on your personal computer, it's probably because you are running Windows. And that might be the topic of interest, and I'll put that up there right here, working in the command line in bash. I'll put that on the agenda. Bash and the command line interface. Hello, Desmond. All right. Now that we define the init method, we're going to define the bark method. Notice the bark method is a method that doesn't belong to the pet class. It's something special for the dog class. So we'll define bark, self, and what it prints is bark. There's the sit method. That is another method that doesn't belong to objects of the pet class, but is something that belongs to a dog object. So that means we have to define it. Notice we are defining the additional functionalities of objects of the dog class. So define sit, self, and that one modifies the upright attribute to be false. Okay. Do let me know any questions as I flesh out these additional 2 methods. Let me look at the chat, what is going on here. Yes, RDX, you are correct that in order for you to run a bash command through the notebook, you need to use a exclamation mark. So for example, let's say I want to use the ls command. I don't have to open up a terminal. I can run it directly through the notebook by using exclamation mark ls. This is great because you can run those commands directly through the notebook. For example, if you want to change your, let's say you want to use a cat command or use a head command. It all can be done by having an exclamation mark at the beginning. So this signifies something running through the terminal. All right, so let's take a look at this dog class right here. And notice, let's go and create an object, my dog, create our dog, and we'll give it a name. We'll call it Wolfie again and say it's 10, whatever unit that is. Define that right there. And we can do things like my dog, bark, and it barks. We can do things like, let's print out whether it's sitting down. So I say my dog, and I call it upright. Looks like it's upright. And then I can say my dog. We say my dog, and we say, let's say sit. And then let's print out my dog upright. All right, so we checked it up. It's upright, and then we called sit. We checked it's upright, and now it's false. And now, what we can go ahead and do is, let's say my dog, and I call speak, and I say hello. My name is, use an F string, and I say dog.name. Nice to meet you. And there it is. Hello, my name is Woofy, and nice to meet you. So notice the dog object has a speak method. However, when I look at the definition, the class definition, the template for dog, I don't see a speak method. I see bark, sit, and the init method. But where do you think, how is it that this object of a dog class, why does it have a speak method? Why do you think that is the case? Okay, let's see. Yeah, it's from the pet class, from the superclass. Exactly. Because it inherited from the pet class. All right, thank you guys. All correct answers. So yeah, so we explore the concept of inheritance. We have a base class, in this case called pet, and we create another class called dog, but instead of reinventing the wheel, we're going to improve on the wheel. So we make sure our dog class inherits from pet. Now, let me take a look at the chat and I see a couple things. And what I did right here is probably not the best thing. So I apologize what I did there. What we really should be using is super. So let me go ahead and backtrack and explain this a little bit further. Is we could have done self.name and self.age and then self.upright. We could have done this right here. But once again, what is a problem with, while this will give us the correct answer, the correct functionality and behavior, why is this not a good thing to do? Why is this not a good thing to do? What am I violating? So RDX, regarding your question, I believe it's some sort of secret code that is happening. When we use the exclamation mark, in Jupyter Notebook, what it does, there's probably a terminal running in the background that you're not aware of, that's not so apparent. And every time you see an exclamation mark, it's taking this code here and it's running it through that terminal that is running in the background. So it is some sort of, secret kind of going in the background. That is why you don't have to import anything specific in order to use this functionality. Let me know if that does answer your question. Yes, redundancy. Because you could make mistakes and things could not be repeated. Yes, dry. Yes, exactly. Thank you, guys. And I am sounding a bit like a broken record. And I say, what is wrong with this? We're repeating ourselves. But it's a very important concept, this idea of do not repeat yourself. So what we need to do is we need to think about it. Our init method for this dog class is pretty much like the pet class with just an additional attribute. So what we need to do is we say super, and yes, someone is saying overriding the attributes of the parent class. So keep in mind is if I create a method that has the same name as the parent, then I'm overriding what I inherited. So with inheritance, we're going to inherit all the methods and attributes of the parent class. However, if we were to redefine it in our child class, it's going to override the parent. However, if we want to make use of the parent method and attributes, we're going to use the super method. And you think super is basically saying, hey, give me the super or the parent class of this class. So I can say super, and I can say, give it dog and self, and say init, name, and age. So when this is executed, you think what's going to do, it's going to say, okay, I'm going to look up the parent of dog, pass self, the argument self, and it's going to go here and basically execute this functionality right there. So we can just erase this right here. And we'll just move this to the next line just to, probably more logical to call the parent method and then create the upright attribute. And notice we are not repeating ourselves. And it seems trivial because we only had two attributes. But imagine if this had 10, right? You'd have to copy all that and paste it there and make sure you didn't do any copy and paste. We are not repeating, we are repeating ourselves. So a better approach is to invoke the init method of the parent of dog and then flesh out the rest. All right, So yes, RDX, it's more of a mere convenience, and I would definitely not try to rely that if I were to push it into production. All right. So hopefully, Naya, I did answer your question about super, so thank you for pointing that out. What I had before was not the best approach. We should use super. So we use super when we need to call upon the functionality of our parent class. Because sometimes the new method we want to create is very much like the old one with some additional functionality. So we'll call the old one of using this pattern here, and then we flesh out the rest. Okay, do let me know if there are any follow-ups. I'm going to look at the chat for any additional topics I brought up, overriding the... do let me know if there are questions. Something else on the agenda, a list of dictionaries. How do you return a specific element in each dictionary? A list of info about dogs. Return a list of dog names. Okay, so I'll put that right there on the agenda. List of dictionaries. Return a specific element in each dictionary. Okay. Someone's asking about import pandas. So no, it's not. If you do import pandas, then I need to do pandas dot data frame. So it is different. All right, so Vera is asking a question about the VC mini project. Is there a particular question? So one thing that I've noticed is that in the VC mini project, open that up, and keep in mind that what we do, if we go here into our playlist, I create thumbnails for all the videos, which will make it easier for you to navigate to see which office hour, past office hours was we discuss a certain topic. So do make use of that feature. But I want to point out for the VC mini project, it's sometimes a little tricky. And if I go here, one thing to keep in mind is that you need to have the REPL method written exactly as required. Because if not, then you will get a score of 0. That includes a space and a capital P. And oftentimes I've been noticing that's a common mistake. You need to make sure your REPL method is the same, it is correct throughout. So capital P and a space. So Vera, do check on that. But also look at past office hours video to get your specific question answered. But do let me know if that helps out, if that answers, that resolves your issue. Okay, so I'm going to go ahead and move on from inheritance. I'm going to look at a couple of things that brought up. Someone is asking, I have a list of dictionaries. How do I go about returning a list of dog names? So for example, I have a list of something like dog names, like Rover and age. And I'm kind of curious, since we're all coming from different parts of the world, if I'm kind of curious to see what is a very common name for a dog in your country. I know in the US, Rover is a very stereotypical name for a dog. I'm not sure if anyone names their dog Rover these days. Right, maybe there's a dog named Snoopy and they are 13 years old. I'll say 70. And let's say we have another name and we call this Puppy. Someone named their dog Puppy. And it's 13 years old and so forth. So I'll call this data. And I have a syntax error because I probably missed out some sort of separator. This should be name colon, I've got age. Same thing here, I forgot about age. And if we say for D in data, so we're going to iterate through this list, and then we can index and get the name, then we get a list of dog names. So do let me know, Lyndon, if that was what you're looking for. Someone's saying, where can I get past office hour videos? Well, if you go here onto your Jupyter Hub and you go all the way to the bottom, we have the office hours playlist. Take a look at that link, and there are the past office hours. So I really do think that the space issue is probably what's causing the error. So do make sure that is corrected. Okay. So Lyndon, do let me know if that answers your question when I look at the chat. I know Kinja's been asking a question about reduce, so I can go and re-examine that question. Okay. You have a list of lists with 3 elements, for example. Go ahead and copy and paste that. And get the sum of the elements, like sum of 1, 4, 7, sum of 2, 4, 8, and sum 3, 6, 9 into a new list. All right, let's examine that. I'm going to call this data. So we have a list of lists. I've heard about the Mars rover such as Curiosity. Okay. So you're asking, how do I come up with a list of, let's say, 1, 4, and 7, 2, 5, and 8, and 3, 6, and 9? All right, let's try that with reduce. So essentially what we want to do is we want to add these corresponding positions. And what we need to do is we say reduce, we say lambda, and we say accumulate and val. Accepts 2 arguments, the accumulator and the next value of our sequence. And what we're doing is we're going to return a list that's the accumulator, 0. So that's the 0 index of the accumulator plus the 0 index of val. And we replicate that. As the first argument is the function, and the second argument is, and I got to import data, unfortunately, from func-tools, from functional tools, import reduce. I get a list index out of range. So calling upon some 0, 1, and 2, the accumulator should have 3 arguments. Sorry, 2 positions. So let's see, where is this? Messing this up on. There we go. So Kinjal, do let me know if this answers your question about the reduce. Notice when we talk about NumPy, the better approach, if you were dealing with maybe a bigger set of data, is to convert this to a NumPy array and invoke the appropriate method for NumPy to calculate the corresponding sums. All right, Kinjal, do let me know if that answers your question. Let's go look at the agenda. Let's see what else we need to tackle. So we talked about inheritance. Oh, by the way, I didn't show an example of using inheritance in real life. So let's go ahead and complete that. And I'm going to show you the notebooks we have on Unit 2. Well, I can't show you these notebooks, or I can't give you these notebooks. Let's see. I will show you issues of using inheritance. So if I go into data course, this awaits you in Unit 2, and let's say I'm going to go into time series. The time series notebook, analyzing time series data. Let me just blow this up so it's a little easier to read. I notice here I have a custom class. I call this index selector, and guess what? It's inheriting from a class called base estimator and a class called transformer mixin. Let's see what else. Here's another custom class called Fourier components. What does it do? It inherits the base estimator class and a class called transformer mixin. So yes, the idea of inheritance will show up once again when you move on to Unit 2. Here's another example. Base estimator, we create a custom class called full model, inherits from base estimator and regressor mixin. And this idea of inheritance is going to come into play because in the realm of machine learning, for some reason this package called scikit-learn, it provides a lot of functionality for you to use for your machine learning workflow. However, it cannot provide everything that you need for your problem. But what it does provide you is a way to extend its functionality. So you don't have to create everything from scratch. While it is possible to create everything from scratch, you're frankly just going to waste your time. What you do, I want to create a regressor that isn't provided in the package, no problem. I will inherit from what's already created from this base estimator and this regressor mixin, and then add my functionality. So yes, inheritance will show up again. I do like to highlight certain skills that do appear in Unit 1 that will appear in Unit 2. So, with that said, going back to this example here, as you'll see in the videos this week, there's a package called NumPy that will allow us to do these type of calculations a lot easier. So what I get to do is I'm going to create data array, data, and I got to import NumPy. Forgot to do that. Import NumPy as NP. And I call data array, and I'm going to calculate the sum. And notice I want to calculate, you can arrange this matrix. Let's go and rearrange this, how this looks like visually. I have 1, let's see what those numbers were, 1, 2, and 3, 1, 2, and 3, 4, 5, and 6, 4, 5, and 6, 7, 8, and 9. And I want to calculate the sum down the columns. So since I want to calculate the sum down the columns, I'm going to use the sum method. But I'm going to say access equal to 1. Since 1 refers to columns, 0 refers to rows, so we want to calculate the sum down the columns. Sorry. We want to calculate the sum down the rows. Sorry, so that's access equal to 0. So this is going to return to us a new array of 12, 15, and if I do my math correctly here, 18. It says go over here in our notebook, access equal to 0, and now I create a NumPy array of 12, 15, and 18. Alright, so go and let me know if there are any follow-ups here. A little quick introduction into NumPy. We can talk more about NumPy throughout this week since it is the focus of this week's lectures. Someone is saying, I was wondering how to do the same without any packages. Without any packages, this is how you would do it. All right, let me take a look at the chat going on. I see someone, Charu. Yeah, I miss you guys too. But hopefully you're learning a lot in Unit 2. RDX is saying about Python packages, whether we can create Python packages, and I can put that on the agenda. And this might serve as a good topic. Okay, no voice, no video. All right. Okay, I am back. All right, thank you guys. Sorry about that. Looks like my internet had a hiccup. I lost my connection briefly there for a minute or two, but I am back. So thank you for letting me know that I am back on the air, and we can go ahead and pick this up. All right. Looking at the chat, I see some conversation about the PW mini project, and if I were to rank the difficulties of the mini projects, I would say the PW mini project is the hardest. So we can always work our way through that. It is a tough one. It is challenging, but hopefully you'll feel very accomplished as you go through that and work on that. All right. So thank you guys for letting me know that I am back online. And someone had brought up a question about this time it functionality, and let's go and discuss time it. All right. So Jupyter Notebook provides a way where we can easily time how long a given cell takes. And that is through the time it functionality. So for example, I can define, let's say I went to, how about this? Let's say I want to calculate, see how long it takes to use reduce to calculate this result here. And I want to compare it with using NumPy. So I run that there. And that's what it does, it's going to run this cell here. But remember that if I run the cell multiple times, I'm going to get slightly different answers. So what it does, it tries to run the cell as many times as possible within a given amount of time. So that's what it's doing right there. Like it's taking a while. Maybe I do kernel reconnect. Maybe I just interrupt that. All right, so it looks like if we were to read this message here, it took about 900 nanoseconds with about a standard deviation of 100 and mean, and it gives us a sort of statistics of the process here. So what it's doing, if I remember this correctly, what it's doing is that it was able to run, looks like 1,000,000 times. It was able to run this cell at least 1,000,000 times. And from all those runs, what it does, it calculates the average, calculates a confidence interval. We'll talk about this later in the course. And it says it gives you a good idea of how long it takes to run this cell here. Notice it ran for a while because it tries to run as many times as possible without taking too long. How many different trials? Let's use time it on data array.sum, x is equal to 0. And I got data array, doesn't know what that is because I probably have, did I not define that? Because I spelled it, misspelled it there. All right, so let's see how long that takes. And that took 3 microseconds. So it looks like it was in fact faster to use the reduce method, probably because it's such a small array. In fact, the other reason is reduce here is returning it's doing some sort of lazy valuation. So it's probably not storing the results in memory, so it's a lot faster. But if we were to blow this up to larger arrays, we'd see that using the NumPy package would have been better. But nonetheless, we used TimeIt, and notice it ran, looks like about 100,000 times, and each run took on average about 3 microseconds, with a standard deviation about 40 nanoseconds. All right. Do let me know if any follow-ups with TimeIt. So I was saying, what does the enumerate do? Well, enumerate returns gives us an iterable. The enumerate gives us an iterable. So if I have, let's say, my list, let's say my list of A, B, C, and D, enumerate gives us an iterable which will yield to us not only the values of the list, but its index. So I can say I val in enumerate my list. And if for this example here, I just want to print out I and val, and have a syntax error because I am perhaps forgetting 4. Yeah, exactly. All right, so can you explain the code within the Gaussian algorithm where TimeIt is used? No problem. Let's take a look at this there. And let's see. Where is, maybe just we use time. Gaussian. All right. Let's see where exactly. So RDX, is that what there you're talking about? All right, so let's examine what's going on here. So the nice thing about TimeIt is it can do this valuation very, very quickly and give us the results without having to write our own code. However, what if we wanted to make use of those trial runs? We want to make use of that because maybe we want to do some analysis ourselves or plot the results. If that's the case, then we have to do it ourselves, unfortunately. And that's what we do here. So we're going to import the time module. And this here time module gives us time-like functionality in Python. Things like able to check what is the current time right now, and then later on check the time. We can find the difference in the elapsed time. We can do sleep. We can have a process sleep for some determined amount of time. So I'm going to go here. Let's import time to see its functionality. Import time. And I can do things like t0 equals time.time. You might want to print out what t0 is. And if I remember correctly, t0 tells us the number of seconds. When we call time, this time function, what this does, it returns to us the number of seconds since January 1st, 1970. We can use this as a starting point. We can say time.time. Yes, the Unix epoch. That is correct. So let me just verify that. t0, and I divide by how many seconds are in a day, and I divide by how many days are in a year. I get about 50 years, which makes sense if I do my math correctly. Right, it's been 50 plus years. Return the number of seconds since January 1st, 1970. So in other words, I can do this, and I can do something like, I don't know, data array.sum access equal to 0, and I want to see how long it took. So then I take another time, I say t elapsed equals time.time. So figure out how many seconds have elapsed now since January 1st, 1970, and subtract from what we had before, You can think of this as sort of a stopwatch. We start the stopwatch, then we stop the stopwatch. And I can print out some message here saying elapsed time, t elapsed. Yes, x is equal to 0 here means the fact that if I don't specify x is equal to 0, it will calculate the sum of all the elements of the array. But x is equal to 0 means calculate the sum, but go down the columns. Go down the columns. Sorry, down the rows. So it calculates the sum for each column. So x is 0 is rows, x is 1 is column, yes. If I say x is 1, it will calculate the sum across the columns, so it will give us the sum for each row. All right, so here we are doing time it by scratch. We start the stopwatch, we stop the stopwatch right here, and return the elapsed time. I thought x equals 0 was column-wise, and it's confusing. If I say sum, that's all of them. If I sum axis equals 1, and I say sum axis equal to 0. Let me just flip this. 0 and 1. And I think I have, is this, let's see, as an example, what does data array look like? And confusingly, looks like, let's see, 136, 512, and I don't know why, I forgot to run. There you go. Okay, so let's go back here. I'll go in, sorry, I'm kind of jumping off topics. But let's go explore this here. So if we look at what's going on here, we create an empty list, and we basically run this multiple times. We run the experiment multiple times. And we append the result to our ever-growing list. And once we have our ever-growing list, we can do things like calculate the sum, calculate the average of all the runs, and display the results. So that's what is happening in the PY algorithms, while we could use the time it built-in functionality. The problem with that is that if we want to further analyze the results, like plot it, visualize it, we don't have access to that data. So here we had to do it by scratch and do it multiple runs, which we do there. So do let me know if that answers your question about time it. And what I'll do is I'll switch here. It's a little confusing, but in NumPy, if I have an array, and I've kind of butchered that array, so let me just go ahead and draw it out once again. If I have 1, 2, 3, 4, 5, 6, 7, 8, 9. If I call sum without any arguments, it will calculate the sum of the entire array. That is the default behavior for NumPy. You calculate some aggregating function on the array. It does so for all the elements of the array. If you say, let's say, access equal to 0. And I know it's a little confusing, so the way that I like to read it in my mind is if I say access equal to 0, that means I want to calculate whatever I'm doing, in this case the sum. I want to do it down the rows. So axis equal to 0 means down the rows. And why rows? Because 0 refers to rows. So calculate the operation down the rows means you do this down the rows, down the rows, down the rows. So in other words, you calculate the operation for each column. So it's a little confusing. I get it. This was something that I was very confused about when I was learning this stuff. So you're not the only one. If I say axis, which is why I'm spending a little time on it because it is confusing, axis equal to 1, then what that happens is calculate the operation across the columns. So across the columns, across each of the columns, across each of the columns, and across each of the columns. This is across the columns, which is what 1 refers to. So hopefully that clarifies the issue. Like I said, it is confusing, so I wanted to take a moment to dissect that. All right. Someone is saying they're facing kernel stability issues with the PW mini project, although only PW is running. Any workarounds to make it faster? Let's say a better algorithm maybe. Yes, so if you're running issues with the PW, like your kernel is dying, it's probably because you're doing things inefficiently. So that's sort of the short answer, but we can go ahead and work through. I do plan this week to work through the PW mini project starting tomorrow, so we can take a look at it and make progress and see what things that you've written, why they may not be working so well as the things that we can work on together. So that is the agenda. Let's go ahead and wrap things up. So thank you guys for coming to office hours. With that said, have a good rest of your day and see you tomorrow.